We have solved we have solved linear inequalities, and now we are ready to solve systems of linear inequalities. Remember, a system is two or more equations that work together at the same time. And typically with linear equations, we were looking for the point of intersection. Where do the two lines intersect? With systems of linear inequalities, we are looking for where those two half planes overlap. What are all the points that are in common of the two linear inequalities? It's done just like graphing normal linear inequalities. You're just going to do two. So first I have y is less than or equal to negative 2/3 x minus 3. Notice both of these are in slope-intercept form. So there is my y-intercept. My slope is negative 2/3. So I'm going to fill up the graph. It's particularly important with these that you go from edge to edge on the graph. Okay, so this is a solid line, and it is everything less than or equal to that, so I'm going to shade below the line. So there's the first line, and then the second one is y is greater than or equal to 3x plus 8. So my y-intercept is 8, which is right here. I don't have room to go up 3 and over 1, so I'm going to reverse that. I'm going to go down 3 and left 1. Double check that your line has positive slope. Fill up the whole graph. If we were looking for, let's say this is a solid line, so let me go ahead and do that. If this were just a system of equations, all we would care about is this point, right? But this is linear inequality, so now I need to graph the other one. It's y is greater than that line, so I need to shade from the line going up. So I'm going to shade this way. And my answer, my solution, is this overlap over here. I have the two solid lines, and then where the two shadings overlap, we call that the cross-hatching. That's the solution. Now, you might have to give a point that is in the solution. So look at that area. Now, there are lots of points over here, right? You could name any number of points, but pick one point that is in the solution area. So I will pick, just as an example, I will pick that point that is in the overlap of the two solutions. And that has coordinates negative 1, 2, 3, 4, 5, 6, 7, negative 7, 0. That is only one point, but that is one of the points that is a solution. For our next example, notice that both of these are in standard form. So take the 7x plus 3y is less than or equal to negative 4 and convert that to slope-intercept form. I got y is less than or equal to negative 7/3 x minus 8. Now, pause the video again and graph this linear inequality. It was a solid line. Notice I had to reverse the slope so that it would fit on the graph. And I'm looking for where y is less than or equal to that line, so I shaded from the line going down. Okay, next I want you to take the next line, x plus 3y is less than or equal to negative 6, and I want you to pause the video and convert that to slope-intercept form. I got y is less than or equal to negative 1/3 x minus 2. Now pause the video and graph that linear inequality. That was also a solid line. It was also less than, so I shaded below. Notice that I shaded that my shading I did to a different angle from the others, okay? So you want to be able to see where the two shadings are and for it not to look like the same shading, Okay, so this area right here, and this would go on forever, right? Because the plane doesn't stop at -10. Um, this area right here is your solution area. So I want you to pause the video a second and tell me a point that is in your solution area. I chose the point -5, -3. There are many number of points you could have chosen as long as it is in this area. It can be on the line and it could be the intersection of the line, but anything in this area. Now I have the line x minus y is greater than 3. Change that line to slope-intercept form. I got y is less than x minus 3. Notice that the inequality reversed because I had to divide everything by -1. Now graph that linear inequality. When the slope is 1, you can put all sorts of points on these graphs, can't you? This has to be a dashed line, and since it's less than the line, I shaded below the line. Now, the next one, x is greater than or equal to 6. That's one of our special cases. Remember, if it's just x, it's a vertical line. So I go over to x equals 6 on the x-axis, 1, 2, 3, 4, 5, 6. X is 6 on that whole line, right? That makes it a vertical line. It's a solid line because it is equal to. Now, where is x greater than 6? This is a vertical line, so it's a little different. Well, here's x equals 7, x equals 8, x equals 9. So everything greater than 6 is like a number line, right? It's going to go to the right. So I'm going to shade this way. And then my solution is this overlapping area. So if we wanted to, we could pick a point on that. We won't do that for this particular problem. Here's one more system. We have y is greater than or equal to -1. When it's y equals a number, that is a horizontal line. The y-intercept is -1. I'll find it here in a second. The slope is 0, so this is a horizontal line and it's equal to, so it should be solid. Now, where on the graph are all the y's greater than -1? This will be above this line, so I'm going to shade this way. Next, I have 5x plus 3y is greater than -18. Pause the video and convert this to slope-intercept form. I got y is greater than -5/3 x minus 6. Now graph this linear inequality after you pause the video. I got a dashed line. I shaded above the line, and my solution area is this area of overlap. So I want you to pause the video and I want you to give me one point that is in the solution area of this system. I picked the origin. It is in the area that overlaps, so 0, 0 is one of the many solutions to this system of linear inequalities.